What up, what up? Today we're going to talk about the ungodly form of factoring ax squared plus bx plus c where a is not 1. It's kind of difficult. Lots of guess and test with this one. Can be frustrating at times, but I will be your tour guide through your frustration. First thing you're going to want to do is you're going to look at the number in front of x squared. I'm going to list out all the factors for it. I'll show you what that looks like. Then you're going to look at C. You're going to list out all the factors for that. I'll show you what that looks like. And then your job is to try to find combinations to see if they kind of multiply and then add up to B. So kind of a bizarre process. Again, I've been teaching math for almost 20 years and people ask me, is there a definitive way of doing these types of problems? And the answer is no. No, there's not. There's just, people have methods. There's this thing called the block method, I think. There's this thing called the imposter method. I was thinking Among Us. But, I don't know. This is the way I do it. This is the way I like it. So in rule number 1, I said list out all the combinations for A. So what that looks like is I'm going to have 5 and 1. That makes out, those are the factors that make 5. Over here, I have several more options. I have 2 and 6, but I'm also going to write out the other version, 6 and 2. I have 3 and 4, so I'm going to write out 4 and 3. What else multiplies out to 12? I have 1 and 12, so I'm going to write out 12 and 1. Now what I do is I kind of predict what I think it's going to be. I'm going to take 1 and multiply it to another one of these inside numbers. I'm going to take 5 and multiply it to one of those outside numbers. Then I'm going to add the product of what I think it is. So I'm just going to do the first one, demonstrate what I'm talking about. I'm going to try to match up 5, 1 with 2, 6. I'm going to multiply the inside numbers. 1 times 2 gives me 2. And I'm going to multiply the outside numbers, 5 and 6. That makes 30. I'm going to add them up and see if I get 19. I don't, which means the first option is not the right option. So if you kind of look at things and say, all right, well, I know I'm going to multiply the interior numbers. I know I'm going to multiply the exterior numbers and then add them up. So let me guess what I think is right. Well, we definitely know it's not the first one. So let's just try. Multiply the inside numbers. 1 times 4 is 4. Okay. Multiply the outside numbers. 5 times 3 is 15. Okay. Add them up and see if I get 19. I got 19. So what does that mean? That means I set up a set of parentheses. I have 5 attached to my n, and I have 1 attached to my other n. So I have 5 and 1, put it in that order. Then I'm multiplying it to 4 in the left parentheses and 3 in the right parentheses. Now I could rewrite this out, get rid of that 1. Let me see if I have an eraser small enough that'll just do that for me. Bang, bang. And I double check my work. 5n squared, 15n, 4n, 19n, and then 12. So that's my process. I don't have a name for it. I'll call it the Nicholas Perich method of factoring wacky quadratics. The Nicholas Perich method. I like it. Okay? Weird. Let's do another one. Okay. List out all the factors. 1 and 2. That's it. List out all the factors for 2. 2 and 1. And 1 and 2. Pick one that you think it is. I think it's that one. and multiply the interiors. So that's 2 times 2. That gives me 4. Multiply the exteriors, 1 times 1. That gives me 1. Add them up and see if you get the coefficient attached to your middle variable. I do, which means I set up my parentheses. What goes here? 1. What goes here? Well, first off, let's do the things attached to n. 1 is attached to n, so 1n. 2 is attached to n, so 2n. So first thing in the first parentheses, first thing in the second parentheses, second thing in the first parentheses. So 2 comes from that something that's not attached to any variable. 1 comes from something that's not attached to any variable. There you have it. Let's get rid of the 1 in front of that n by erasing it. Works for me. Okay. N times 2n is 2n squared. N times 1 is 1. 2 times 2n is 4n. So there's your 5 n's. 2 times 1 is 2. The Perich method. Okay? I have to click that one. No, of course it gets worse. Now, look, let's take care of the first guy. Think of 2 guys that multiply out to 3, 1 and 3, or 3 and 1. It really doesn't matter. 4. Now, here's where we have to be careful. Since this guy is negative, I need to pick 2 negatives that multiply out to 4. So negative 1 times negative 4 do that. Negative 4 times negative 1 do that. And negative 2 times negative 2 do that. And I'm not going to write down negative 2 times negative 2 again. All right, so let's pick what we think it is. I think it's u. So let's multiply the insides. Let's multiply the insides. That gives me negative 3. Let's multiply the outsides. 1 times negative 4. And ooh, I was so close, because when you add them up, you get negative 7, and that's not what I wanted. Boy, does that steam me. Boy, does that make me angry. So it wasn't the first one. I was wrong. I didn't know that would happen. Let's try the last one, because I don't have a good feeling about that last one. Let's try that last one. So the first one didn't work. 3 times negative 2. 3 times negative 2 is negative 6. 1 times negative 2 is negative 2. Add them up, you get negative 8, which is the number in front of n. It's exactly what I want. So let's write out our parentheses. 1 is attached to n squared, so 1n. 3 is the second one attached to n squared, so 3n. Negative 2 is the first guy not attached to anything, so negative 2. And negative 2 is the second guy not attached to anything, negative 2. Let's get rid of that 1 in front of n by erasing it. N times 3n, 3n squared. N times negative 2 is negative 2. Negative 2 times 3n is negative 6, so negative 6 and negative 2 make that negative 8, and then negative 2 times negative 2 is positive 4. Very popular. Very popular. Last one. Oh, but it's a doozy. It's a doozy. That's the eraser. All right, 1 multiplies out to 4. 1 and 4 does. Oh, and 2 and 2 does. Interesting. Over here, we have to write out all the possible combinations. So you have negative 1 times 25. You have regular 1 times negative 25. You have negative 5 times 5. You have regular 5 times negative 5. Also, I have 25 times negative 1. I have negative 25 times positive 1. And I think that's it. So let's just try a random one that I know will not work. Let's try a random one that I know won't work. Okay, multiply the insides. 4 times 1 is 4. Multiply the outsides. 1 times negative 25 is minus 25. Add them up, you get negative 21. It doesn't work. So it's not that one. Now, some of you might be thinking this method is great, but if I were to try all of these, I would literally try 1, 2, 3, 4, 5, 6, 7, 8, 12 of them. Yeah. And you might be thinking, can I just guess and test? Yeah. But if guess and test isn't working, this is a surefire way that no matter what, if you try all of them, you will hit one. So that one didn't work. I'm trying to find one that will. How about negative 15? Let's try. These are too big. Too big. Let's try one of these. 2 times negative 5 is negative 10. It's not that. I already decided this is not going to work. Negative 10. 2 times regular 5 is regular 10. So that becomes a 0. I should have known. So let's get rid of that one. It's not you. It's not you. Oh, I think I see it. I think it's this one. Let's get a different color. Let's get purple. 2 and 1. Make. No, that won't work either. I'm going to have to fast forward through this. That won't work. I see it. No, I don't. I see it. It's this one. 4 times negative 5 is negative 20. 1 times 5 is positive 5. Add them up, you get your negative 15. So when we write them all out, right, 1 gets attached to n. The second one that's attached to n is 4. You have negative 5 in the left parentheses. You have positive 5 in the right parentheses. We can erase this guy. So again, what you saw was me legitimately trying to do a problem without knowing the answer. You saw me guess 2 of them that just flat out didn't work, or 3 of them, whatever it was, that just flat out didn't work. Eventually I came to the answer, and that's kind of the frustrating part about these types of problems, is they may take a while. But if you use this method, you will not go wrong, except for wasting a whole lot of your time. And time is precious. And I appreciate your time. So, as always, thanks for watching. I love you. Like and subscribe. Bye.